MW Fly. Have you heard of them? They're Italian, they're quality driven, they make aircraft engines, and they're ready to fly. All right, everyone, welcome to another episode of the Experimental Aircraft Channel. Talking to you with MW Fly all the way over in Italy, so that's why we're doing this Zoom format again. But they've been posting quite a bit on social media recently, really pushing a couple different offers they've got, and so I want to reach out and find out what's going on. I've heard the name MW Fly in the past. I understood it to be a European company with a distributor in Canada, but now it seems that they've got a distributor in the USA and a couple other changes. So I want to bring them on and find out what's new and what's going on. So guys, over in Italy, introduce yourself and what's going on.
Hello, this is Stefano Marella. I am the CEO of MW Fly.
I am Guido Fantini, CTO of MW Fly.
Welcome. And you got Nicholas down here from, is it Missouri?
It is St. Louis, Missouri.
Okay, well, welcome.
Thank you.
Thank you.
All right, guys. Stefano, how about telling us just a little bit about, again, the Instagram version of MW Fly, how it came to be, when and where, and that kind of stuff.
Okay, the history of MW Fly started in 2003 when we started the project of the engine for aircraft application, and we, after almost 10 years of experiment and development, we start to sell the engine in 2012. So the engine didn't stop the development, and now we are proposing a new version of engine that we call a Spirit. That is what you were talking before about our Facebook post and the promotion that we are doing right now, because that is a brand new engine based on the previous version, but with a lot of innovation respect the previous version.
Excellent, excellent. And Nicholas, how did you get involved in all this just recently as a U.S. distributor or whatnot?
Yeah, I kind of fell into it purchasing the previous demo aircraft from the gentleman who was representing them in Canada. So I purchased the Sonics recently with a couple partners and kind of fell into it that way. Got to know the guys in Italy and really enjoyed working with them. So moving forward with representing them here in the U.S. and trying to give them the name here in the U.S. because I think they have a good product offering.
Awesome. And that is a Sonics, and which horsepower version are you running in that?
It's right now it's about 115 horsepower because we have it revving a little higher on the ECU custom map, but it's the B22D is the version that's in it. The 2.2 liter displacement with direct drive.
Awesome, awesome. And I understand that it was already, I think, flying in Canada, but then you had to re-register in the U.S. So you're in the process of doing that, and it should be flying when?
The airworthiness certificate is going to be done here the first week of June. So I'm hoping to have it up at Oshkosh so people can get some, take a look at the engine and get more familiar with it. So that's where we're hoping for. We just got to see what our phase 1 hours are going to be. See if we can get that flown off in time for Oshkosh, but that's our hope.
Awesome, awesome. Okay, well, look forward to hopefully seeing you at Osh with that, to be able to put hands on it and get some real good video footage of that. Switching back over to Stefano, guys, what's changed recently? And I'll just roll right into, also which engine models are you producing as a whole?
Actually, we produce 16 different engine models, 8 plus 8, because we can very simple change the revolution direction of the prop. So the same version are available in left or right rotation. Then we have a version with gearbox or without, so direct drive or geared. And for each geared version, we can supply two different ratios to have different power output.
Okay. And what are the different horsepower? So you've got a total of 8 models, and you kind of divide that up 4 and 4 there.
So,
what is the horsepower range of the different models? Hey, thanks for joining me on this episode. Let me show you who's made all these videos possible. Awesome companies like Dynon Avionics at dynonavionics.com, Airtech Coatings at airtechcoatings.com, Airworx at airworxaviation.com, and visit our website at experimentalaircraftchannel.com for events, our video library arranged in easy-to-find playlists on specific topics, affiliate products, aviation merchandise, and so much more. All right, everyone, before we jump back in, if you like these videos that we are producing weekly, rivet down that like button and engage all notifications by hitting that bell so you don't miss a single episode. Remember to check out the description below this video for links and special affiliate offers available to you.
the range starts from 100 to 160 horsepower and is obtained changing the displacement. We have two different available displacement, 2.2 or 2.55 cubics. And obviously we can change the engine speed. So the direct drive maximum speed is 3,400, and the geared version can turn until 4,700. Different.
Yeah, I was gonna say that. So what is the purpose of it? You offer both of the direct drive and the gearbox. So what was the real purpose of bringing on the gearbox option within the same platform? What is the advantage of having that?
Well, there are different applications of the engine. There are some aircraft like the Store that it's much better to have a gearbox engine to have a very good traction and torque. And but there is some market that prefer to have a direct drive. So that's the reason. But anyway, the reason is that the engine has been designed to have a separate gearbox, just to have a separate also lubrication of the engine and the gear. So that is why we have this opportunity to have all these different solutions.
Okay, so in short, you're designing something that has the mechanical advantage of a gearbox for a high torque situation, which could be either a helicopter or the STOL performances that's going on these days. So Nick, going back to you for a second, I assume then you're running a direct drive in your Sonics?
It is. It's a direct drive.
Okay. And and that's 115 horsepower direct drive. So what kind of RPM are you running in the Sonics, which I would assume is a much smaller prop because it's a bit of a smaller landing gear and that kind of stuff. And which size prop are you running?
It's a 54-inch prop, and the RPM on mine set a little higher, so it's not traditional. I mean, I have it running to like 3,800 red line right now.
Wow. Okay.
So it's kind of it's probably not standard, you know. But
Gotcha.
the engines are meant, you know, the ECUs are meant to where you can really flash, you know, I mean, the engine can run up to 4,700 RPM. So in a direct drive format, I mean, but if coming from the factory, most of your direct drive like UL Power or even Jabiru, all, you know, typically go to that 3,400. So that's kind of what they had it set from the factory. And I think mine was just ran a little higher to produce a little more power.
Okay. Well, on that note, jumping back to Stefano here, talk to me about the ignition system, fuel system, charging system. Is it air-cooled, water-cooled? The real basics of this engine. Is it carbureted? Is it fuel injected? Talk to us about that.
Yeah, I speak about this. The engine are fuel injected. we use two injection ACU, both in the same case, and so the injection is a full redundancy system. The ACUs are
And just a second, is it a port injection or direct injection, or what kind of injection system are you using?
is indirect injection system. So the injector are in the inlet port, and so before the inlet valve. Okay.
Okay.
And this is an electronic injection. So the gasoline is the gasoline pressure is on 3.5 bar, is regulated by a mechanical regulator, is a valve. Okay, the pump are two and two gasoline filter. Each pump can deliver 100 liters per hour maximum, and they can be drive together in a critical operation, for example, takeoff or landing. Okay, normally you use only one. We can have also an automatic system to have automatic switch between the two pumps. For example, if the fuel pressure drops below 3 bars, automatically can be switched on the auxiliary pump. Okay.
Okay.
The injection is full redundant because the two SU are working together. The first one is the master, the second one is the slave, and they are connected by a CAN line, so they can change together data and working data too. So
Okay.
the secondary injection knows the working status of the master one, and if there is some fault, the master becomes the auxiliary one. Okay, they switch. The ignition is also redundant. We have 8 spark plugs and 4 double output coils. Is an inductive type, and we have altimetric and barometric compensation for injection and ignition too.
Is this a magneto style, or is it electronic ignition, or?
It's full electronic. We have a phonic wheel and 2 pickups that can sorry, they can understand where is the
for the identification of the position of the crankshaft.
Okay,
So
yeah,
there is
the crankshaft position
is a
sensor.
typical
Okay.
flywheel without one teeth.
Okay.
So the SU can understand where is the position of the injection is the injection is phased.
Gotcha. Hey, Nick, going to you for a second here on your Sonics. Go back to there for a second. Are you running like an in-tank type of pump? Because I think the Sonics has like a center header tank, or do you have wing tanks for that fuel system?
It's a header tank, yeah, and it goes from the header tank in the Sonics into a fuel pump.
Okay.
Yep, it's a very clean install. I can send you some more pictures, but it's very, very clean install. You know, the ECU is mounted, and then the radiator underneath. It comes for a very clean install.
Okay, and guys, is this the charging system? Is it an alternator, a generator? Is it a direct drive, belt driven, or what's the charging system?
It is a generator, is a permanent magnet generator. 300 watts.
Okay, so is that mounted at the rear of the engine or something like that directly with no belt, or like gear drive?
No belt. But you can add an auxiliary generator belted with the prop axis.
How many amp?
Is 63.
63 amp. Okay.
Yeah.
And this is completely air cooled, a mix of air and water, or
No, it's completely water cooled.
okay.
That's why water is better to have good cooling in each part of the engine, and also better for stability and engine reliability, because for example, if you fly at 6,000 feet, and when you have a long landing, the cylinder becomes very cold with air cooling, not with water cooling.
Shock
So
cooling.
the thermal stability of the engine is much better with water. We have included in the system a thermostat valve that regulates very well the max and minimum temperature.
Okay.
I want only add a question about the injection system. Our injection system is able to work also without battery or without the generator. So we had a test where we simulate generator failure, and I can say you that with a 16 amps per hour battery, we can the engine can run for 59 minutes. The ECU switched off when the voltage drop below 7.2 volts. Okay.
Wow. Okay.
Or the engine can run also without battery, only with generator. And I think is the once engine fuel injected that can work without battery.
So do you have this system set up basically then completely two separate wiring harnesses do you recommend two different batteries as well?
Yeah, we can.
Okay.
Yeah.
Okay. All right. Well, let me also back up just a few minutes here. And this is a horizontally opposed water-cooled engine, which is very popular in aviation, of course. And it looks kind of like maybe an automotive style. Did this get an influence from an automotive? Is it a conversion from some type of European? Tell me the origins of the design of this. Did it come from an automotive design that was changed? Because you said it was kind of a clean sheet, which means this is your own, correct?
Yeah. Well, we decide to break down with some tradition with the aviation engine, and we have a background of in Lamborghini, my colleague, and Ducati, myself, and so we have let's say a knowledge of engine of the technology, engine technology right now. So we decide to use what is the best solution also for our engine, but keep in mind the safety aspect. So we decide to have a water-cooled engine, a gearbox engine. That is the main stone of our project. So that is so it's not a copy of any other engine, because well, there is no time, but I will explain to you all inside the engine the feature that we have adapted for the engine. But is as my partner say, we start from a blank sheet.
Understood. Understood. And I'm gonna roll into some other questions here too. Nicholas, being that you're still waiting on registration, you've probably done a lot of ground runs and taxi testing at the moment. What has your predecessor, if you will, if you've got 70 hours on the engine, 140 on the airframe, kind of test phase has he gone through, which would be probably the most recent that you could share?
Yeah, he flew about 70 hours on the engine. And the one thing that impresses me the most, at least in my testing since I've had it, is how easily it starts. I've never seen an aircraft engine. I mean, if you have the fuel turned on, it's first crank immediately. It's pretty impressive as far as how easily it starts. It's just a push button start. You flip on each ECU and push start, and you're ready to roll. Okay. Super easy operation. It's all pretty much FADEC, full FADEC. So everything is pretty much, you have a single throttle lever, your ECU switches, and the push start, and that's it. So very easy operation overall. That's the one thing I've enjoyed the most.
Gotcha. Did they share the logbook, if you will, like the first 40 hours? I'm not sure if Canada is exactly the same as us, as flying off the first 40 and having a good test phase for that, and maybe what was accomplished during that time.
They don't really have the same phase one. It's a little bit different. But the logbook entries, they did try a lot of different props. That's the one thing, that kind of stuck out to me, to get things right. But he was really, the previous owner was shooting for a record, like a speed record with it. But I know I think I've seen photos of 135 knots true at about 1,200 feet. So not too bad performance wise, but I don't know about a speed record. He flew it for about 70 hours, and he wasn't flying as often anymore, and he flies as a CFI now. So it was sitting more than it was flying. So that's kind of why he got rid of it.
Got it. All right, go back to Stefano, guys. So, what at your end, from a manufacturer standpoint and designer standpoint, what kind of testing has gone into it? Whether initially, of course, on the ground, and then in aircraft. Talk to me about that for a minute.
Yeah, we performed 2,000 hours with the test bench. So it's an American test bench. Maybe you know, is a Dynon land and sea test bench. Is a water test bench. So we can simulate in the testing room all condition that you can find in flight. Anyway, you know that an aeronautical engine has to be proved with prop, because this is an important accessory, we can say so. And
the prop is an accessory, yeah.
It's the main accessory. And with the prop, we perform 800 hours of tests in different conditions. Here, mainly in Italy at the moment. And that was necessary to have a feedback about vibrations, about mixture, about drivability. I don't know how to say differently. And so it's important to have a feedback, obviously.
What was talking is about the test that we have done before we start to produce the engine to sell.
Yeah.
Because now we have already produced 2060, more than 2060 engine, and so we have a much more hour on the engine. But of course they are on different engine. As Nicholas, that one just flew 70 hours.
Right, right. So how many different airframes have you installed these engines in, and how many are flying? Which aircraft and how many are flying?
It's the model engine model, the aircraft model are more than 50, and some of them some of them have very few hours. Some of the most I know they have been reported to be, because they come back for maintenance, they have 400 hours at the moment. So we have Tecnam, Zlin. Basically, most of the application are stall aircraft like Zlin, Savage, Savannah, and Zenair, or helicopter.
So the Zlin, which is bringing the Norden here really soon, I think probably before Osh, as people might be familiar with the Zlin Norden, but they also have the Savage, and then
Savage,
Savage, and Shock Cub.
The Shock Cub. So it's flying in that platform, in that airframe. Before we get into price, because that's the really big question, is how much does this weigh? What is, like, in your lower end of the spectrum horsepower, your 100 horsepower? What is the weight to that, all the way up to your biggest 160 horsepower? What is the weight? And what I mean by weight is basically everything needed, including accessories, to run. Understand that different airframes might require something a little bit different, but what comes in the package with your engine, and what does it weigh?
So the weight is 74 for the direct drive versions, independently for the displacement, and
74 what?
Kilos.
74
kilos. Sorry.
Okay.
We only use kilos.
Yeah, just having clarity here across the world here.
And 79 kilos for the geared version. So the difference is 5 kilos.
And that's the 100 horsepower model?
Yeah. No differences about the weight.
Okay.
This weight is dry without accessory. And what you have to consider is the total weight to fly. And this is 100 for gearbox. Okay. Ready to fly. And 5 less for direct drive.
The 100 horsepower direct drive is 6,000 euro. That is okay. And for the most for the red line 160 horsepower is 27,000 euro. That is the range of the price.
Wow. Did you say 6,000 or 16,000 for the 100 horsepower?
16,000.
Okay.
And
I thought I heard 6,000. I was going to wow. I've got this on video. Let me order one right now for 6,000 euro.
We are very, I think that we are very competitive with the high power setup. I mean, the price is very, we think.
Got it. Well, thanks again, guys, for coming on today and sharing what you're doing over there. And I look forward to hearing more and seeing more about this engine. And Nick, again, I'll catch up with you at Osh, hopefully.
Yeah, that'd be great.
All right, everyone. Thanks for tuning in today, and
Thank you.
I'll see you in the next episode. Remember to rivet that like button and engage all those notifications. Thanks for watching this week's episode. Be sure to check out experimentalaircraftchannel.com. I'll see you in the next episode. Thanks for watching.